right? So 2 to the x is equal to 8. That the only way that can happen is if x equals 3, because 2 to the third power is 8. But what I need for you to notice is that now you do this in your head, but keep in mind that really why this works is that 8 is really 2 to what power? The third. And what do you notice about the bases of this exponential equation? They're the same. So there's something called the one-to-one property for exponents. All right, so the one-to-one property for exponents. So basically, if you have an exponential equation and the bases are the same, then the exponents have to be equal. So this exponent has to equal this exponent. Okay? So if the bases are the same, then the exponents have to equal. So that's called the one-to-one property for exponents. One-to-one property. So this x has to be this 3.
Okay, so the one-to-one property for exponents. If the base is the same, the
exponents have to equal. Yep. Okay, number 2. All right. Suppose you had 3 to the x minus 4 equal 81. Okay, so the directions will say solve this exponential equation. Now, the one in my math lab and the one in the worksheet go a little bit further, and it will say solve using same bases. So solve using same bases. So you can rewrite this to where those bases are the same. So what are those bases do you think they need to be? 3. So this is base 3, so that's prime, right? There's not else you can do with that base. 3 is already a prime number. Now remember, one of the things you learned in the past was that all composite numbers can be written as a product of prime numbers. So all composite numbers can be written as a product of prime numbers. See this 81? I can write 81 as the prime number 3 raised to what power? 4. So I get that. And now, since the bases are the same, I can use the one-to-one property for exponents. So what that means then is that this exponent has to equal what? That exponent. So x minus 4 has to equal 4. So I went from an exponential equation to a linear equation. And so you add 4 to both sides, and you found what your solution needs to be. So x has to be what? 8. And in this case, it's easy to check. If x is 8, what's 8 minus 4? 4, and 3 to the 4th is what? 81. So the answer is 8. All right, so remember, you got to get the bases to be the same, rewrite it to where the bases are the same, and then you're going to use the one-to-one property for exponents. Number 3, suppose you had 4 to the 3x minus 2 equal 8 to the x power. 4 to the 3x minus 2 equal 8 to the x power.
So we make them 2?
Okay, so you got to figure out what base you're going to use. Now, is there any way you can get both bases to be a 4?
Yeah.
Now, if you say that, you got to think about this then. See this 8? Can I write 8 as 4 to a whole number? No. Or 4 to an integer? No. 4 squared, 4 cubed, 4 to the 4th, 4 to the 5th, 4 to the 0, 4 to the negative 1, 4 to the negative 2, and so on. That's never 8. So you can't. So then you got to rewrite both of those with a different base. So think of what prime number can I use for 4 and 8? 2. Because 4 is 2 what? Squared, and 8 is 2 what? Cubed. So you can use base 2. Now here's how you're going to write this. Now you got to be careful with the next step. So the next step is this. See this 4? You're going to rewrite it as what number? I mean, what expression? 2 squared. So you can say 2 squared in parentheses. Put that in parentheses. See how I circled this 4? Put 2 squared in parentheses. There's a reason you have to put in parentheses. But that's also being raised to what power? 3x minus 2. Okay, equal, and then we'll come back and discuss this part in a little while. Equal, now let's do the 8. 8 is what? 2 cubed in parentheses, and it's being raised to what power? The x. Okay, so that was your next step. So you had to rewrite this using a common base. And the only common base that would work here that makes sense to you is base 2. Now remember, when you have a power raised to a power, what do those exponents? You multiply them. Remember the power rule? You multiply. Remember in the previous course, if you have 3 to the 4th power raised to the 2nd power, that becomes 3 to what power? The 8th, right? That's for the 8th. 4 times 2 is 8. You multiply them. So mistake people will make is they'll say that this power times this power, these two exponents multiplied together, they'll say that's 4x minus 2. Is that correct? No. Yes. So what you got to, that's a 3, I'm sorry. 6x minus 2 is what they would say. But it's really 6x what? Minus 4. So what you need to remember is that this 2 is being multiplied by this binomial. So it's really this, 2 times 3x minus 2. That's what it is. And so when you distribute, this becomes 6x minus what? 4. So this right here, I'm circling this. So I'm going to rewrite this power to a power as 2 to what new exponent? 6x minus 4. Equal. All right, let's do the other one. This one's a little bit easier because you don't have that binomial. Those are both monomials. So that'll be 2 to what power? 3x. So that's where I'm at. Okay, so notice what we did. So we had to get the bases to be the same. And the only base I can use that makes sense to how we're dealing with this is base 2. And then I had to use the power rule to get rid of the parentheses. See, I put parentheses. Now I've got to get rid of them. So I got rid of the parentheses using the power rule for exponents. And I'm here. Now, what rule do you think you're going to use next? What property? Yeah, so this property, right? The one-to-one property for exponents. So the base is the same. So you're going to use the one-to-one property for exponents. So the base is the same, then what must be true? The exponent. So 6x minus 4 has to equal what? 3x. So I went from an exponential to a linear. All right. Now, what do you want to do next here? Subtract 3x. Okay. So if I subtract 3x, you need to be careful. So that's 6x minus 3x is 3x, correct? Minus 4. Now, some students, they don't know how to deal with this. Well, you need to. This is equal to what? 0. Okay, so 3x minus 3x is 0. Some students leave it blank, and it's like, well, why are you leaving it blank? It's supposed to be 0. 3x minus 3x is 0. And now what's the next step? No, don't divide yet. Add 4 first to both sides. They combine like terms, and then I get 3x equal what? 4. And so x is what? 4/3. That's your x. Okay? Let's look at this one. All right. So exponential equations getting the bases to be the same. All right, suppose we had this. Suppose we had number 4. We had 9 to the 2x minus 1 equal 27 to the x plus 2. Yeah, there's no way you can use base 9, right? Because 27, there's no way you can write 27 as 9 to a integer power. But you do know that in terms of prime numbers, what prime number goes into 9 and 27? 3. So I'm going to rewrite 9. I'm going to circle it to remind me. I'm going to put that in parentheses. I'm going to rewrite 9 as 3 what? Squared. And don't forget your outer exponent. What's my outer exponent? Okay, equal. I'm going to write 27 as 3 cubed. What's my outer exponent? X plus 2 is the outer exponent. So it's 3 cubed raised to the x plus 2 power. So that will be your next step. All right. And then we use the power rule for exponents. So power raised to power. What do you do those powers that I'm circling?
Yeah, 4x minus 2.
Yeah. So you're going to say 2 times 2x minus 1, right? And then distribute. You get 4x minus 2. So that's 3 to the 4x minus 2. Is that right?
Yeah.
Equal, over here, power raised to power you multiply, so that's 3 times x plus 2,
3x plus 6.
3x plus 6. So that's 3 to the 3x plus 6. And then do what?
4x minus 2 equals
Yeah, so what property am I going to use to go from here to the next one? What property is 1-to-1 property?
There you go. Thank you.
All right, so which says that if the bases are the same, then the exponents have to equal. So 4x minus 2 equal 3x plus 6. So I went from an exponential equation. See, that's exponential. Why is this an exponential equation? Because the variable is in the exponent. And this is linear. Okay, so let's just bring the variables to the left. So I'm going to subtract 3x. So 4x minus 3x is x. I get x minus 2 equal a 6. Add 2, what's the answer? X equal 8.
That was not awful.
Yeah, that wasn't too bad.
All right, so all you're doing is just trying to get the bases to be the same. All right, let's look at, let's see. Okay, so on your, let's just do one more with this, and then we'll look at another kind. Suppose you had this. Suppose you had 16 to the 2x minus 3 equal 4 to the x plus 5.
Four? No, the base is 4.
Okay, now, all right, so some of you said the base is, you're going to use a base of 2. Okay, true, you can. But can I use the base 4 here? Yes. So do you always have to resort back to a prime number?
No.
No. In the others I did. But notice that 16 is for what? Squared.
All right.
So 16 is 4 squared. Now I'll do it both ways. I'll use base 4 and I'll use base 2. But base 4 is the easier one to use here.
We don't have to do both.
Well, you make sure you know how to do both, right? If you say no, girl. All right. So 16 is 4 squared, correct? Raised to what power? And so I'm going to leave this one alone, correct? All right, power raised to power, you do what? Multiply. So my first one's going to be 4 to what power?
4x minus 3.
Yep, and that's equal to 4 to x plus 5. And then what's the next step?
4x minus 6 equals x plus 5.
All right, subtract x. So I get 3x minus 6 equal 5. What's the next step?
Add 2 equals 5.
All right, so 3x equal 11. So what's x?
3 equals 11 over 3.
11 over 3. Now let's do the same problem using base 2. We still got we better get the same answer, right? So let's use base 2. Use base 2. All right, same one. Let's use base 2 instead. All right, so 16 is 2 to what power? 2 to the 4th, right? And all that's being raised to what power? 4 is 2 to what power? And all that's being raised to the... All right, good. All right. A few more steps and you're done. So power raised to power, do what to those powers? All right, now be careful. If some of you are still going to circle and you're going to mess up, you're going to say 8x minus 3. So if you're prone to do that, then write it out. Say 4 times 2x minus 3. And now you have to use what property? Distributive property. So that's 8x minus 12? 12, right? So that's 2 to the 8x minus 12, correct? Equal, and then this will be 2 to what power?
2x plus 10.
2x plus 10. All right. And now I'm going to use the one-to-one property for exponents. And so when the base is the same, then what else must be true?
8x minus 12.
So 8x minus 12 must equal 2x plus 10. All right, what's the next step?
Subtract 2.
So this is 6x minus 12 equal 10. Add 12. Combine like terms, I get 6x equal 22. Then divide both sides by 6. And then reduce. I get x to be 11 thirds. Get the same thing, right? Okay. All right, and that's all that was, just getting the bases be the same. So you should be okay for that worksheet 4.4 part 1. So that's one of those that you picked up. So if you look at it, 4.4 part 1, that was these right here. Okay? So that was that one. So there's just 3 problems on that. It's not that difficult. It's not. You can do this. You can do this. All right, now, what if you had this, though? What if you had this?
What if we had that? What if we What if we did? How about we just go? Or no?
2x equals 5. What kind of equation is this? Exponential. All right. And the way we just did it was we rewrote it to where the bases were the same. Is there any way you can get the bases to be the same? No. So I cannot do this one like I just did.
Is it still part 1?
No, that's now part 2.
Okay, 4.4 part 2.
Okay, so now I cannot get the bases to be the same. But I want to solve for the variable x, right? Where's the variable located? I got to get it out of the exponent. So watch the motion here. What allows me to take this right here? You're looking at me. You're supposed to look at
I
that.
already looked at it. I'm thinking. I already
Okay.
thought about it.
So watch the motion. What allows me to take this x and pull out in front?
The power rule.
What needs to be there, though? A log needs to be there. A log needs to be involved here in order to take the exponent out of, in order to take the variable out of the what? Exponent. I've got to solve for x. So what allows me to do that is a logarithm. A logarithm allows me to do that. Now remember what you've always learned. What you do to one side, you do to the other. All right, so I'm going to go ahead and rewrite this again. Now, a logarithm is a function. So if I want to take the log of the right-hand side, and notice I'm using what base? 10. I could have taken the natural log, right? It does not matter. It does not matter. We saw that a while ago. But what I do to one side, I do to the other. So if I'm going to use a calculator on this, then either I'm going to use the common logarithm or I'm going to use a natural logarithm. And watch how simple this is now. Now I can rewrite this using what property, what rule? Power rule. So this becomes x times the log of 2 equals the log of 5. X times the log of 2 equals the log of 5. And I'm trying to get x by itself, right? If you look at this, what am I doing to x right now? I am multiplying it by the log of 2. What's the opposite of multiplying by the log of 2? Divide by the log of 2. Divide by log 2. Divide by log 2. And then the log 2's divide out, right? Anything divided by itself is 1. So that's x equal log 5 divided by log 2.
Is this just a base change?
No, that's not base change. We didn't use base change at all here. Okay? That's not base change. All right? Now, you see that on that worksheet 4.3? Take that out. 4.4 part 3. Part 2. Take part 2 out. 4.4 part 2. 4.4 part 2.
I was confused.
4.4 part 2. Okay, now, you see this right here? Right here. That's what you're going to put here. See in the directions it says, express the solution in terms of natural logarithm or common logarithm. Then use a calculator. So right here, see where it says answer terms of logarithms? That's what you would put here. You would put, I'm going to just say log 5 divided by log 2. You see what to put there? When you get x by itself in terms of logarithms, that's what goes there. You understand that, right? Okay, now the approximation goes here. So on your calculator, let's approximate this. So you would say on your calculator, you would say the log of 5, close the parentheses, divide by log 2, close the parentheses, press equal, and I think it said 4 decimal places. No, it says 2. So 2 decimal places, so it'll be 2.32. 2.32. Now, if someone had used a natural logarithm, what would that look like? What do you think x would equal if the person had said it had used a natural logarithm? What do y'all think? No. The first part though.
Oh, natural log 5 divided by natural log.
Yeah, and you should still get what? 2.32. Okay. All right. Now let's look at this one. Number 7. Suppose in number 7 you had 10 raised to the x plus 2 power equal 5. Now, notice that one of the bases is what? 10. And I know that the log of 10 equals what? 1. So if the base is 10, you don't want to use the natural logarithm. You can, it doesn't matter, but use the common logarithm. Because if you use a common logarithm, then at some point you will end up with the log of 10, which is just what? 1. Right? So you can take the natural log of both sides, or you can take the log of both sides. But if it's base 10, it is preferable to take the common logarithm of both sides. Now, first of all, do see there's no way you can get the base to be the same? Don't say 10 is 5 squared. It's not. 5 squared is what? 25. 10 times 2 is, 5 times 2 is 10. All right, so you can take the log of both sides. What I do to one side, I do to the other. Just like this, right? Now, what do you think is the next step based on what we just did? The power rule. So this exponent, I'm going to bring out in front, right? So that's in parentheses x plus 2 times the log of what? 10. Equal log of 5. All right, so that's where we're at. Now remember, trying to get x by itself. Now don't make it difficult. Don't distribute. Don't say, well, I'm going to get rid of the parentheses by distributing. You can, but you're making it more difficult on yourself because you know this is just what? 1. That's just 1. The log of 10 is 1. Don't distribute this. You're making it much more difficult. No, that's just 1. That's just 1. So x plus 2 times 1 is just what? X plus 2 equals log 5. And when we're stepping, you're done. So how do you get x by itself? Subtract 2. And so the answer is this. The answer is x equals log of 5, subtract what? 2. Now, don't make the mistake and say that's a log of 3. It is not. All right, don't, because that's not 5 minus 2. That's a log of what? 5. Whatever that is, you subtract what? 2. So that's it. That's all you do. So, but you have to use the fact that the log of 10 was 1. Huh? What? What do you mean a regular 2? What?
Raised to 2 is what he's asking.
No, that came from the x.
It came from the other side, it's just a regular 2.
Just look at the equation.
So yeah, it's like a regular. It's not a subscript.
Okay. All right. So if it's base 10, use log. Because at some point you'll be able to use the fact that the log of 10 is 1. It'll make things easier on yourself. Okay, so number 8, suppose you had an e. So number 8, suppose we had e to the x plus 3 equals 7. So e to the x plus 3 equals 7. So the base is e. It is preferable. It makes things a lot easier on yourself if you use what base?
Natural log.
Okay, base e, which is natural logarithm. Because you know that the natural log of e is equal to what? 1. So I'm going to take the natural log of both sides. Just like this. Oh, I forgot to do the approximation here. Let's go back real quick on your calculator. Now, remember that your first answer would be this, right, in that box? Because the direction says write the answer with the logarithms. Now, do your approximation. Now, be careful. Don't say the log of 3. We talked about that. That's not 5 minus 2. That's the log of 5. Whatever that is, you subtract 2. So you're saying log of 5, close the parentheses, and then subtract 2, and you get negative 1.30. Okay, negative 1.30. Okay? All right, let's go back to the number 8. Number 8. Okay, number 8. What's the next step, do you think? Power rule.
First turn the natural log into 1.
No, you got to do the power rule first.
Oh, bring it to the front. Yeah.
So that's x plus 3 in parentheses times the natural log of e equals natural log of 7. And what's the natural log of e? And x plus 3 times 1 is just x plus 3. And one more step and you're done. What's
Take 3 from both sides.
yeah. And so x equal natural log of 7 subtract 3. So that'll be the answer in the first blank. And then approximating this to 2 decimal places, you would say natural log of 7 subtract 3. You get negative 1.05. So make sure you get negative 1.05. All right. Can you get the basis to be the same? No. But I need to get that variable out of the exponent. So again, it does not matter whether you take natural log of logarithm here, because none of the base is 10, none of the base is e, so it does not matter. Natural log?
Yeah.
Okay.
Because,
So the natural log of 73x equals the natural log of 6. So you can take the natural log of both sides. Okay, so then you're going to use what property?
power.
All right, so I get 3x natural log of 7 equals natural log of 6. All right, now be a little bit careful with this. Huh? No, you don't need that here.
Use the products.
Yeah, why wouldn't you put it in?
Why wouldn't you put it in parentheses?
I want to put the 3x in parentheses because that's being multiplied by the natural log of 7. The only time you want to put that in parentheses would be if you had the natural log of 7x, and the 7x was the argument. I mean, you could put this in parentheses, no big deal. It just makes it look,
No, I'm speaking directly to the fact that in the previous question we put the exponent.
because that was a binomial. That's a monomial.
So we don't use.
No. So the reason here, if you had not used 1,
Okay.
if you had not used 1, you would have had to distribute. So I see what your question is now. So you would have had to distribute, right?
Right.
Okay,
Now I do.
so you'd have to distribute. So you'd have to say x times the natural log of e plus 3 times the natural log of e, which would make it more difficult.
Right.
Okay, over here though, that's a monomial. So don't make the mistake and say that's the natural log of 3 times the natural log of 3 times the natural log of 3 and x times the natural log of 3. That's a product. That's a monomial. So you're not distributing at all here, right?
No.
Okay. So since that's just a monomial, leave it without the parentheses. And the reason for that is the next step, you've got to get x by itself, correct? All right, so remember, if I cover this part up right here, how would I get x by itself? Divide by 3. If I cover this part up here, how do I get x by itself? No. You're still multiplying, right? Divide by ln 7, the natural log of 7. All right, so x is being multiplied by two factors, a 3 and a what? Natural log of 7. And what's the opposite of multiplication? Division. So what you're going to do here is you're going to divide both sides by 3 and a what? Natural log of 7. So you would divide both sides by 3, natural log of 7. So that's probably, if you don't remember this from years ago, this is probably the first time you've seen that kind of problem, where you divide by two factors.
Okay, so what, right, just leave the x out, you're trying to solve for the x.
You're trying to get x by itself. So right now, if I have 3x, you all know divide by 3, right? If I just have natural log of 7 times x, you all know divide by what? Natural log of 7. So do you see that I'm really multiplying x by two things? What's the opposite of multiplying by two things? Divide by two things. Divide by the two factors. And it kind of makes sense because what's 3 divided by 3? 1. What's the natural log of 7 divided by natural log of 7? 1. What's left? X. You're trying to solve for x. You always solve for the variable. Always solve for the variable. All right, so that would be the answer to the first blank. That would be, that's it. That would be the answer to the first blank. Now, using your calculator becomes a little bit tricky now. Because in the past, if I go back to the one we did, let's say here, using a calculator here was easy. You see it? Because that was just a one factor here, the log of 2. So you just divide by the log of 2. Here, though, you are dividing by two factors, a 3 and a what? Natural log of 7. So I'm going to show you two ways you can deal with this. All right. Now, here's what you have to do. Okay, so there are two ways. You have the numerator, that's the easy one. The numerator is just natural log of 6. So natural log of 6. Close the parentheses. All right, now look carefully. If I have this, and what I'm about to do is based on this idea. If I have 8 divided by 2 times 2, okay? That's really 8 divided by what? Which is just what? 2. Okay, now listen carefully. Do y'all agree if I cover this right here, 8 divided by 2 is what?
4.
And then divide by this 2 is what? 2. So I can take 8, divide by 2, whatever that is, also divide by the other 2.
Okay.
So when I do this, I can take the natural log of 6, divide by what?
3.
3, press equal, and then divide by what?
7.
Natural log of 7. Using this idea from in the past. So 8 divided by 2 is 4, and then divide by 2 is now 2. So here you would say natural log of 6. So watch this. So you gotta press your enter button first. The natural log of 6, divide by 3, then press equal. Then I take that and divide by what? Natural log of 7. And then there's your approximation.
Okay.
So 0.31. Okay, 0.31. All right. Now here's the other way. The other way. All right, now listen. We have natural log of 6 divided by 3 natural log of 7. That was this right here, right? Okay, I'm going to rewrite it this way. Look. So in my denominator, so whatever the natural log of 6 is, I'm going to divide by this denominator, correct? So I'm going to put this denominator in parentheses just like this on my calculator. Put parentheses on my calculator. So watch. Look at this and look what I'm doing. The natural log of 6, close the parentheses, divide. Now I've got to input what now? Parentheses, then 3 times the natural log of 7. Now notice the natural log of 7, you got to close that 7, right? Then you got 2 parentheses, very good. And then close that one, and then notice you get the same answer, 0.31. So it's up to you which one you want to use, but make sure you kind of see it both ways.
Can you do the first way real quickly one more time?
You say the natural log of 6, divide by 3, press equal. Then divide by the natural log of 7. You got to press equal after you divide by 3.
You close that parentheses,
Yeah, always close the parentheses with natural log of 6.
and then you just open another parentheses, or just hit.
No, you say this. You say natural log of 6, close the parentheses, divide by 3, equal. Then divide by natural log of 7. Close the parentheses, equal.
Your salary from yearly to or to like hourly.
Okay? All right, so notice the 2 approaches. Some of you may want to just leave it like this, put the parentheses around them. It's up to you, but you may want to do it both ways to double check, because you could have messed up here. So if you do it both ways and get different answers, you know something's wrong. Okay? All right, let's look at number 10. Suppose you had this. All right, number 10. Suppose you had five e to the 2x equal 7. 5e to the 2x equal 7.
I would use natural law.
Okay, you would definitely use the natural log at some point, yes. But would you take the natural log of both sides first?
No.
No. Because you need this coefficient right here to be a 1. So you have to divide by 5 first. You got to have this coefficient be a 1 before you take the log or the natural log of both sides. You need this to be a 1. So right now, multiplying this exponential by 5, the opposite of multiplying by 5 is 2. Divide by 5. So you got to get that, do that first. So these divide out, and you get e to the 2x equal 7/5. And now do what? Take the natural log of both sides. And so now I can pull out the 2x, correct? You agree? So that's 2x times the natural log of e equals the natural log of 7/5, just like this. What else can I do?
You can make the natural law 1.
The natural log of e is 1.
So you divide by 2. No.
Yeah, at some point you divide by 2. Let's just write it out first. But you all agree that this is 2x, though, right?
Yes.
Now how to get x by itself. And that would be this right here that I'm writing, the natural log of 7/5 divided by 2 would be the answer for the first blank. That will be the answer for the first blank. Now use your calculator for the second blank. So the natural log of 7/5, so natural log 7 divided by 5, close the parentheses, then divide by 2. It's like this. Equal, and you should get 0.17. So that'll be the second blank.
And we're putting 7/5 in parentheses because it's a fraction only being multiplied by the natural log.
Now remember that that's not multiplication. So common mistake people think is that natural log of 7/5 here means natural log times 7/5. That's not what that is. See, when you read it, you read it as the natural log of, right?
Right.
In the past, normally of stood for what operation?
Multiplication.
Yeah, but that's not what this is. So it's a natural log and logarithms are functions. So you're taking the log of this number. But you use parentheses because it's a fraction.
Okay.
If it was just the natural log of 8, you wouldn't use parentheses because there's just one thing there. If it's a natural log of 8/3, then put parentheses. All right. Okay, so let's look at this. And we can stop.
Oh, Dolores. I'm tired. I can't say it.
Dolores says she knows it already.
I really don't. When they come teach people, how don't I'm supposed to
What's the next step?
divide by both sides by 3.
Yeah, you gotta get e to the x by itself. Okay, so you agree that's gonna be e to the x equal 8/3?
And then we'll do the natural log of both sides.
Yep.
All right, yeah, okay. You can take this chocolate.
And so pull the exponent out in front. So that's x natural log of e equals natural log of 8/3. What's the next step?
Natural log of
Divide by X.
No.
I don't know why I keep doing that.
And x times 1 is just x, and you already have x by itself. So what's the answer?
That's what we're gonna put in the first place.
Yep. And then use your calculator to figure out what that's about. Approximately equal to.
I don't know why I can't get that.
So the natural log of 8 divided by 3, close, equal 0.98. 0.98. All right. Okay, now okay, 6 times 3 to the x equal 5. What are you going to do first?
Divide
Divide by
6.
6. 6 is divided out, so you're left with 3 to the x equal 5, 6. What's the next step?
You can use the regular log. You can do the regular log or
Okay, regular log is common logarithm. So you say common logarithm
regular log. You can do the common log or the natural log.
or the natural log, doesn't matter. Let's just use a natural log.
Okay, so it's your natural log of 3 to the x. Is equal to the natural log of 5.
So take the x out in front. So that's x natural log of 3 equal natural log of 5, 6, correct?
Right.
One more step when you're done. What's the next step?
Divide both sides by the natural log of 3.
Mm-hmm. So the natural log of 3 divided by itself is 1. 1 times x is x.
X equals the natural log of 5 over 6 over natural log of 3.
So that'll be the answer for the first blank. Approximation. What you'll get. You'll get this, negative 0.17. And negative 0.17 is what you need to get. Okay, so natural log of 5, 6 in parentheses, divide by natural log of 3 in parentheses, and press equal. All right. So that's all this is. So you should be able to do those 4 problems. All these. So notice though, in here you have to divide by 3 first. Okay. All right. Just make sure you understand what terms of logarithms means right here. That's this stuff here in those boxes. Right here.
Is there a part 3?
Yes. was a part 3.
Does even does graphing get involved in this at any time?
Not yet. We may not get to it.
Not yet.
We may not get to
There's
it.
the 4.4 part there? It's not up here.
It's not up there. Just so, yeah, I just printed out the part 2. So I haven't done the part 3 yet. It's not on your test, but it is. A couple of things are on your final. So let's just it's the first one's gonna be easy. First one's easy. Watch how simple this one is. It's still the same section. It's a long section.
Still part.
This will be for part 3. It's just not up there. I haven't made it out yet.
Okay.
4.4 part 3. So this is where you start looking at. Now remember, everything we've done so far was an exponential equation, right? We haven't done anything with a log equation. So let's just do the first part with log equation. Then Thursday after your test, we'll look at the second part of the log equations. First part's fairly easy. Watch how simple this is. All right, so we should follow. Suppose we had this one. We had the log base 2 of x equal 3. Log base 2 of x equal 3. So I gave you an easy one here to get you to the idea of how you're going to approach this. So I'm trying to get x by itself, correct?
Divide by log base 2.
No, okay. So she's assuming that this is read as, no, she said divide by log base 2, right? She's assuming that you read this as log times x. Is that true?
No.
No. If this were multiplication, then yes, you divide by that other factor. But that's not multiplication here.
So that's
Okay.
really 2 times x to the third? Is that real?
No, that's log of x base 2 equal 3. That's how you read this. Now you have enough information to tell me how to deal with this. Think about those, huh? But how are you going to do that?
Write it in a different way.
Write it in a different way. This is a log equation. You're going to write it as a what?
As a other one.
Exponential equation.
Yeah.
So that's gonna be 2 to the third.
2 to the third equal x. And so therefore, what's x? 8. Answer is 8.
Okay, you was telling the
So
truth.
so you have to remember all the stuff you've learned with logarithms and exponentials. So remember, you can always go from a log equation to what kind of equation? And you can always go from an exponential to a log equation. That was one of the first things we talked about. All right, now what about this one? Log of x plus 3 equal 2. What kind of equation is this?
A log.
Log equation. You want to change what kind of equation? Exponential.
So x plus
10.
All right, 10 is the base. Very good. 10
10
squared.
Equals to x plus
X
3.
plus 3.
10 squared equals x plus 3. Very good. And so notice I went from a log equation to what kind of equation is this? Linear. No, that's linear.
A linear X. Yeah. It's a linear exponential. Oh, because it's got an accent. Just kidding. I was
Okay,
making stuff.
so what's 10 squared?
100.
100. And then divide, I'm sorry, subtract 3. What's x? 97. And it kind of makes sense. You can always check yourself. What's 97 plus 3? 100. What's the log of 100? Is 10 squared equal 100? Yeah. 10 squared equals 100. Number 3. Log of 2x minus 1 base 3 equals 2.
So 3 squared equals 2x minus 1.
Okay, so you went from a log equation to exponential. I'm sorry, you changed an exponential, but when you multiply this out, that's really a linear.
So 9 is 2x minus 1 plus x is 5.
So add 1, right?
No.
So 10 equals 2x. And then divide by what? 2, so it's x. Oops. X is 5, right? You can always check yourself. What's 2 times 5?
10.
What's 10 minus 1?
9.
Is 3 squared equal to 9?
Yes.
Yes. Right. See what I did to check?
I saw it.
3 squared equals 9.
That is not
All right. 4.
What if you said I had another y and x
All right.
multiply the x multiply the
What?
I need more room.
Oh, my.
Got to make sure it works. So let me see. Let me make this a plus 4. Okay. So don't make it difficult. Here's the idea. If I have, let me go ahead and use this page. If I have this, if I have the log of, let's say 8 equals the log of x plus 2, okay? That's easy enough to where you can tell me what you think x needs to be.
Right, because 8 and x plus 2 have to equal the same thing, don't they? So
Yes.
8
So what do you think x needs to be? 6. 6. Because this is log 8, right? How can I get this to be a log 8? How can I get this side to look exactly like this? Is if x was what? 6. So here's the idea. When you have a log equation, you have the log of both sides. So if the log of m equals the log of n, see how that looks? Then what's true is that the arguments have to equal each other. So m must equal what? N. So m must equal n. So is that the situation I have here? So 8 must equal what? X plus 2. And then you subtract 2, and what's x? 6. Okay? So if I go back over here, then what must be true?
2x minus 1 is equal to x plus 4.
Yeah. And then subtract x. You get x minus 1 equal 4. And then do what? Add 1. So what's x? 5. That's all it is. Okay? All right. Now, what's going to happen?
Is that a certain property, the log of m?
Say it again.
Is that like a rename
So it's
that?
the 1-to-1.
It's a 1-to-1. So it's still it's 1-to-1 property. The early one we used was called 1-to-1 property for exponents. This is 1-to-1 property for logarithms. So if the log of m equals the log of n, then this m must be the same as this n. So the 1-to-1 property for logs. Okay? 1-to-1 property for logarithms. So if you have two logs equal to each other, then the arguments have to be the same. So m must equal n. So where we're headed next is this, and then we'll stop. There's things I got to give you. So here's where we're headed next. So if you go back to this part we talked about in the beginning. So we did something like this. We did this. So this you get the base to be the same, right? This you have to take the log or natural log of both sides. Remember that? And then here you just solve. How we do this? How do you solve for x here? 2 to the 6 equal x plus 3. So here's where we headed next. So this we haven't done yet. But if you notice, if I cover this and then this part looks like something we did at the beginning of class, you see where you're taking the sum of two logs with the same base? You're going to write it as a what?
You're going to write it as a multiplication.
As a multiplication problem. You're going to write as a product. So that's where we headed next with this. So we do that next class period. Okay? Huh? No, you have some things to get, so you're not leaving right away. Okay.